We are going to look at activity 31. This activity begins with lesson 31.1 on page 455. This first lesson is about solving quadratic equations by graphing or factoring. So we are going to use a graph to help us solve a quadratic equation. We are going to use factoring to help us solve a quadratic equation. And then we're going to describe the connection between the zeros of a quadratic function and the x-intercepts of the function's graph. So the situation that they have presented to us here is that Carter, Alicia, and Joseph have built this trebuchet, that's a type of catapult, to launch a projectile through the air, and they're entering this competition. So this graph down here represents the path of their projectile, and the path of the projectile is given by this quadratic equation. So if we're looking at this graph, it shows us the height of the projectile and the distance from the launch point. So if we're looking at this, the distance from the launch point and the height of the object is right here. So when the height of the object is at 0 and the distance from the launch point is at 0, that means that they're actually at the launch point. So this is where they're launching the projectile from. So it goes into the air and then it starts coming down on this side and it hits the ground over here. So this shows the distance from the launch point when the height of the object is 0. Okay, so we can see that the projectile is 16 meters from the launch point here and 0 meters from the launch point here. This point up here, we can see that's the highest point of the projectile, and that is at 8 meters. So we can answer these questions down here that they ask us. How far does the ball land from the launch point? Well, 16 meters. The maximum height of the ball or the projectile was 8 meters. And the x-coordinates of the points where the ball is on the ground, we wrote those up above. That was 0, 0, and 16, 0. Okay? So if we go to the next page, they're showing us this equation here, the same equation from the graph that we just looked at, but instead of having a y, they have a 0. So if we think back to what the y represented in our graph, that was the height of the projectile that they launched. So when the height is equal to 0, that means that the projectile is actually on the ground. So this equation represents when the projectile is on the ground. So they're asking us to verify that x equals 0 and x equals 16 are solutions to the equation. So if we think back to what these numbers represented in our graph, those showed where the ball was on the ground. So these were the two x-intercepts that they gave us. To verify that these are correct, we could plug in 0 for x here and here to show that the equation is equal to 0, and we can plug in 16 for x here and here and show that the equation equals 0. Okay, so if you don't have a graph and you want to tell what the x-intercepts would be of your graph, you can do that using the factored form of your polynomial equation. So what we're going to use is we're going to use something called the zero product property. This just says that if we multiply two things together and they equal 0, then one of those things had to equal 0. So just as a quick example, if we did 5 times x is equal to 0, what does x have to be? It has to be 0. That would be the only thing that would make this equation true. So it's the same idea whenever we are looking at factors that are more than just a single term. So if we look at the equation from the catapult example from above, we still have it equal to 0. Remember, we're looking for the x-intercepts. That's where y is equal to 0. We can factor the equation that they're giving us. So what they did over here is they factored out the GCF. The GCF of this equation is x. So they factored out an x. Now we have two factors multiplied together actually equal 0. So from the zero product property, we know that when two things are multiplied together and they equal 0, then one of those things has to actually be 0. So then we say, okay, well, when this piece is 0, then this whole equation is true. Or when this piece is 0, the whole equation is also true. So we look at that here. They show, okay, when the first piece is equal to 0, it's true. And when this second piece is equal to 0, it's true. The first one is easy. It's already solved for you. But the second one, you can actually get x by itself, which is what they did here. And they show that x is equal to 16. So they just solved this equation that they had. At that point, you have your two solutions, the two x values that make this equation true. These are the two x values that make the whole thing equal 0. These two solutions that we found should look familiar. They're the x-intercepts from the graph on the previous page. So we found the same two x-intercepts. That's a good sign. If the equation represented the graph and the graph showed those two x-intercepts, then those are correct. Okay, let's do one more together and then you can try a couple of them. So we're going to work on this one. We're going to solve this by factoring. So in order to use this zero product property up here that they gave us, notice it has to equal 0. That's the only way that this is going to work. Notice that this equation is equal to 0. Because if something times something equals 0, then we can use that property. So we have it equal to 0 here. Notice this one's not equal to 0 in C, so you're going to have to get that one equal to 0 before you factor. That's really important. Okay, so let's do A over here together. So we have x squared minus 5x minus 14 is equal to 0. We're going to factor the left side of this equation into two sets of parentheses. The first thing that I did, I noticed that there was no GCF here, so I went ahead and opened up my two sets of parentheses, but you always want to check for your GCF first. Okay, so we know that x times x is equal to x squared here. Now we need something multiplied together to give us negative 14 here, and then added together to give us negative 5 here. So that's going to be negative 7 times positive 2. That would leave us with a negative 5x in the middle. Okay, so now we have our factored form of our equation, and we know that this thing times this thing is equal to 0. So if this piece here, if this was 0, 0 times whatever this is, it doesn't matter, is going to be equal to 0. So when is this piece equal to 0? We're going to find out. Same idea here. If 0 times something over here, it doesn't matter what this one is, but if this one is 0, 0 times whatever is equal to 0, then this would be true. So x minus 7 is equal to 0. We're going to solve this. When is this piece actually equal to 0? We're going to add 7 on both sides. So x is equal to 7. That's the first x value that would make this equation be equal to 0. Here we're going to do the same thing. Subtract 2 on both sides. So x is equal to negative 2. So these two x values are, they both actually make this equation true. So we have two answers, and these are the two x-intercepts of this graph. So if you were to set this equal to y and graph this, these are the two x-intercepts. Okay, I want you to try these two. You can pause your video, work on those, and I'm going to give you the answer. Okay, so the answer to part B is x equals 0 and x equals 2. The answers to part C, you get x equals negative 6 and x equals 3. So check your answers. Okay, we're going to go ahead and move on. On the next page, they're giving us another graph. So it's the same idea as what we were doing before. They gave us a new quadratic function here, and we have, we can visually see the two x-intercepts of this graph are 1, 0 and 5, 0. So what we can do is we can take this equation here and we can actually see if we can factor it to find these two x-intercepts and see if we get it correct. So we know that the x-intercept occurs whenever y is equal to 0. So I'm going to replace y with 0. and then we will factor to solve the equation. So there's no GCF, so x squared minus 6x plus 5 factors into x minus 5 times x minus 1. Okay, that gives you that negative 6x in the middle. Now, we know that something times something is equal to 0, then one of these things has to be 0. So I'm going to set both factors equal to 0, and then I'm going to solve. So plus 5, x equals 5 here, plus 1, x equals 1. So did we get the same two x-intercepts as what's actually occurring on the graph? Yes, we did. That means that we did that correctly. Okay. Now, I want you to try another one. Number 11, part B. Down here, they're giving you another example. So pause your video so that you can work on this one, and I'll give you the answer. The two x-intercepts here end up being negative 4 and positive 3. So check your answer. Okay. There's some more problems on the next page that you can work on page 458. The check your understanding down here, you can solve these by factoring. You can identify the zeros of the function. They define that for you up here. The zeros of the function are the x-intercepts. So that's another word for the x-intercepts. Zeros of the function, it's where your graph crosses when x equals 0. When y equals 0. Another word for the solutions of a quadratic equation are called roots. Okay. Now that's lesson 31.1. Let's go ahead and look at lesson 31.2. So we were looking at solving a quadratic equation by graphing, by graphing and by factoring in the last lesson. This lesson is more about actually graphing or learning the parts of the graph. So we're going to be looking at the axis of symmetry and the vertex in this lesson. So we're going to identify the axis of symmetry of the graph of a quadratic function, and we're going to identify the vertex of the graph of a quadratic function. So we're looking at some vocab here in this lesson. Okay, so let's look at this image that they're giving us here. So they're giving us this graph of this quadratic. They're saying that it's in this form, okay, y equals ax squared plus bx plus c. They're showing us the axis of symmetry is that line that goes directly through the middle of your parabola. So if you drew a dotted line down the middle of your parabola and you folded it over that dotted line, there's symmetry there. Okay, so the axis of symmetry can be represented using this equation here. Remember, they're using this form of the quadratic. That's where they're getting that negative b over 2a. They're actually getting it from the equation. So ax squared plus bx plus c. The b and the a in this equation come from these coefficients here. So b is the coefficient of x and a is the coefficient of x squared. That's where those come from. So we're going to look at that in a minute. We're going to actually look at some examples. But we can also look at this graph and see the symmetry here. We know that if this line is actually the axis of symmetry, there's symmetry on both sides, then every single point on the parabola should be the same distance away from this axis of symmetry. So if we look, 1, 2, 3, there should be a point 3 away on the other side. 1, 2, 3. So these 2 points are equidistant from the axis of symmetry. Okay, also I want to point out that the axis of symmetry goes directly through the vertex of the parabola. Okay, that's the only point that doesn't have a symmetrical point on either side of the axis of symmetry, because the axis of symmetry cuts directly through that point. Okay, so what we're going to do using these ideas, and we are going to, in a graph, we are going to find the zeros by looking at the graph. We're going to find the axis of symmetry by looking at the graph, and then we're going to find it using the equation that they gave us. We're going to find the vertex by looking at the graph, then we're going to find it by hand, and we're going to determine the max or the min of the function by looking at the graph. Okay, so we'll do A together, and then I'll let you try B. So the first thing that we're going to do, so 2, 1. Okay, we are going to find the zeros graphically. So if we look here, we remember from the previous lesson that the zeros of the function are the x-intercepts. So we can see that that's going to be -4, 0, and 2, 0. Okay. If we look here at this graph, we can see that the axis of symmetry is going to be at x equals -1. And we can see that the vertex is at -1, -9. So now we're going to look for these things by hand to make sure that we're actually able to do that. So the axis of symmetry the equation that they gave us was x equals -b over 2a. So I'm going to look here. Remember, it's going to be ax squared plus bx plus c. So b in this equation is going to be 2, and a, if there's no number written in front of x squared, a is understood to be 1. So we're going to plug in 2 for b and 1 for a. So -2 over 2 times 1. We end up getting a -1. So our axis of symmetry is -1. Does that match the axis of symmetry that we observed on the graph? It does. We got -1 there. So we know that that's correct. Now, to find the vertex, so let's say that we didn't actually have the graph of the parabola and we needed to use the equation to find the vertex. We weren't able to see it, or maybe it wasn't on a whole number. Maybe it was a decimal value and you would be estimating. This is a way to find the exact value. So you can find the axis of symmetry by hand. Now we can use that axis of symmetry to find our vertex, because we know that the axis of symmetry cuts through the vertex, so they should share the same x value. The x value of the axis of symmetry should be the x value of the vertex. So we're going to go ahead and we're going to use the axis of symmetry. We're going to plug it into our equation, and then we'll find the y value of the vertex. So y equals -1 squared plus 2 times -1 minus 8. So if we simplify this, we end up getting 1 minus 2 minus 8. If we simplify that, we get y equals -9. So the x value was -1, the y value is -9, so we can put that into an ordered pair, -1, -9. Okay, so we have our vertex, so we found it by hand, and it does match the vertex that we observed, so that's good. We know it's correct. And now we want to look at the graph and find the minimum or maximum. So if we look at this function, it has a lowest point, so we know that that's going to be a minimum value. So our minimum on this function is the lowest value, which is -9. So the axis of symmetry is the x value from the vertex, and the minimum is the y value from the vertex. So that works for max or min. It's going to be the y value from your vertex. Okay, so there are some examples on page 461 that you can practice. We're going to go ahead and move on to the next lesson. Okay, on page 462, we're going to look at lesson 31-3. Now we're going to take all of the stuff that we just looked at for the first two lessons, and we're going to actually graph a quadratic function. So this time they're not giving us the graph. We have to take the equation and actually come up with the graph itself. So we're going to use the axis of symmetry, the vertex, and the zeros to graph a quadratic function. Then we're going to interpret the graph of a quadratic function. Okay, so they gave us an example here. They're giving us a function, and then they walk you through all the steps. Sometimes it's kind of hard to look through this stuff. I do encourage you to read through it, make sure that you can understand it. I'm going to go ahead and work through it over here on the side so that you can see it worked out. Okay, so I'm going to rewrite the equation that they have given us. So y equals x squared minus x minus 12. Now we're going to go through all of the steps that you're going to need to go through when you want to graph a quadratic function if you're given the equation. This is one way to graph a quadratic function. There are other ways that the book goes through with you. So this is just one method. Okay, so the first step that we're going to do is we are going to find the axis of symmetry just like we did in the last lesson. Okay, so we're going to use that equation that they gave us, x equals negative b over 2a. Now, if I'm looking at this equation, notice b actually is a negative number this time. It's negative 1, and a is positive 1. So be careful because there is a negative in this equation. So I'm going to do negative b is negative 1. So we have a negative 1 times 2 over 2 times positive 1. So if we simplify this, we end up getting a positive 1 in the numerator and a 2 in the denominator. So our axis of symmetry is 1/2. That's okay. So what we're going to do now, we have the axis of symmetry. We know that that's the x value of the vertex. So we're going to use that to lead us into our next step, which is finding the vertex of the parabola. Once we have the vertex, we have a point that we can actually plot. So we have the x value. I'm going to plug the x value into the function. So y equals 1/2 squared minus 1/2 minus 12. Okay, 1/2 squared, that's 1/4, minus 1/2 minus 12. So you could plug this in your calculator if you need to. You can do it by hand if you need to, or you can turn it into decimals if you need to. So if we took this and we made our fractions into decimals, 1/4 is 0.25 minus 1/2, that's 0.5 minus 12. So that's a little bit easier to plug into your calculator. So the y value of our vertex actually ends up being negative 12.25. We have the x value, we have the y value, now we have an ordered pair. Since I wrote this as a decimal, I'm going to go ahead and write my x value as a decimal. 0.5 and then negative 12.25. Okay, so we have a point that we can graph. The next step we're going to look at, we are going to find 1 point is not enough for a parabola, right? So we need to have more points than that. So we're going to go ahead and find our zeros of our function. That's the x-intercepts, the same way that we did in the first lesson. Okay, so we know that for the x-intercept, the y value is going to be 0. So I'm going to plug in 0 for y. So that's x squared minus x minus 12. Now we factor this to find the zeros. So this factors into x minus 4 times x plus 3. That leaves us with a negative x in the middle. You can check it. Negative 4x, positive 3x leaves you with a negative 1x. Okay, so it is now factored. We know that something times something is equal to 0. One of these things has to be 0. So we're going to set both of them equal to 0. And then we're going to solve each one. So x minus 4 equals 0. We're going to add 4 on both sides. X equals positive 4. Over here, x plus 3 equals 0. We're going to subtract 3 on both sides. So x equals negative 3. Okay, so we have our two solutions here. And we have enough to actually graph. So we have the axis of symmetry, we have the vertex, and we have the zeros of the function. So notice their graph down here, since we were working with those decimals, it looks like they chose a scale of 1/2 on their x-axis, but they used a scale of 2 on their y-axis. So just pay attention to how they have labeled this. If you did this yourself, you can choose the scale that you want to use. So they went ahead and they plotted their vertex, which we found at 1/2 or 0.5 negative 12.25. So they plotted that over 1/2 down negative 12.25. Then they plotted their two x-intercepts. We know that the first x-intercept was 4, so they plotted that here. The second x-intercept is negative 3, so they plotted that here. You now have enough points on your graph to draw your parabola. Okay, so we're going to go ahead and look at one more together. Okay, so they're giving us some examples here on try these A. So we're going to do part B. So I'm going to do the same thing I just did. We're going to go through the same steps that we went through on the previous page with an example that they don't have worked out for you. So I'm going to rewrite it over here. Y equals x squared minus 2x minus 8. Okay, so the first step was to find the axis of symmetry. Okay, so remember that's that equation, x equals negative b over 2a. So b here is negative 2 and a is 1. So negative b is negative 2, so we end up having negative 2 over 2 times a, which is 1. So we get negative 2, that's positive 2 over positive 2, which gives us 1. So our axis of symmetry is at 1, so that also gives us the x value of our vertex. So that's step 2 is to find the vertex. Okay, so we're going to plug in 1 for x, that's the x value, to help us find the y value. Okay, so we have 1 squared minus 2 times 1 minus 8. Okay, so that's 1 minus 2 minus 8. Okay. If we simplify that, we end up getting negative 9. So we have our vertex, we have the x value, we have the y value, so 1, negative 9. So you could actually plot that. Now the next step was to find the zeros of the function, so I'm going to do that down here. We're going to find our zeros. So remember the zeros of the function, the x-intercepts, that's where y is equal to 0, so I'm going to replace y with 0. So 0 equals x squared minus 2x minus 8. And we're going to factor this to solve it. We're going to use that zero product property to help us find this. So 0 equals, open up my two sets of parentheses, there's no GCF. This factors into x minus 4 times x plus 2. Okay, so now something times something equals 0. One of these things has to be 0, so we're going to set each one equal to 0. And then solve. So here, x is equal to 4, and here, x is equal to negative 2. So we have our x-intercepts, and we have our vertex, so we can actually graph this now. Okay, so so I have my coordinate plane here. So I'm going to plot an x-intercept at 4. 1, 2, 3, 4. And I'm going to plot an x-intercept at negative 2. And then our vertex was at 1, negative 9. So I'm going to go over 1, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we now have our parabola. Okay, you could even draw your dotted line if you wanted to through your x or your axis of symmetry. Okay, so there are a few more examples up here that you can work through to get some practice, parts C and D, and there are some in the lesson practice and the activity practice on page 465.